The problem I had most trouble with was problem number 3. In this problem, a navigating spacecraft is far from other objects, so there's no gravity forces acting upon it. The mass of the spacecraft is defined as m, and the motion of the rocket changes due to the rocket engines. The rocket engines are shut off, and the rocket is coasting at a velocity vector of 0, v0, 0. As it passes the location x, 0, 0, the fire thrusters are turned on, and the spacecraft experiences a net force of negative F in the x direction, 2F in the y direction, and 0 in the z direction for a time of t seconds. The ejected gases have a small mass that is so small that is neglected, and this is so that there's no forces, gravitational forces of the gases acting upon the spacecraft. Then the thrusters are turned off, and there's no net force acting upon the spacecraft. And you're asked to find where the rocket is t seconds after the thrusters are turned off. The way I solve the problem is the following. I specify the constants I have as the velocity before the thrusting, v0, and the velocity. I start to find out the velocity after the thrusters are used, which is v final. You calculate v final is equal to v initial plus acceleration times the change in time. You also know that the equation of net force is equal to mass times acceleration. Therefore, velocity final is equal to velocity initial plus the net force over the mass times the change in time. Therefore, your answer, after you plug in your values, gives you an initial velocity of 0, v0, 0 plus negative f in the x direction, 2f in the y, 0 in the z, times the time over the mass. Then you must find the position of the rocket after thrusting. Therefore, you go for R2. R2 is equal to the initial position of the rocket plus the average velocity times the change in time. This is the same as R0 plus V0 plus V final over 2 times the change in time. Therefore, R2 is equal to x0, 0, 0 plus t time over 2 times the negative force t over m, 2 times the v0 plus 2 times the force times the time over mass, 0. Therefore, all of this simplifies to become x0 minus ft squared over 2m, v0t plus ft squared over m, 0. Then you must find the position of the rocket t seconds after the thrusters are turned off. This was the mistake I did in the test, as I calculated the position after thrusting and didn't take into account the position t seconds after thrusters were turned off. R final would be equal to R2 plus B final times the change in time. Therefore, R final is equal to x0 minus ft squared over 2m in the x direction, plus then in the y direction v0 times t plus force times t squared over m, 0. This, which would equal to R2, would be plus time times the velocity final, which is negative ft over m, v0 plus 2ft over m, 0. Giving you the final position to be R final would be x0 minus 3ft squared over 2m, that would be in the x direction. In the y direction, 2 times v0, v initial times time, plus 3ft squared over m, and there's no force or velocity acting on the z-axis. Hope you like this tutorial.